Hi friends, let's draw the isometric projection of combination of these two solids. Here we have a cube of 50 mm side. Over that a sphere of 50 mm is placed. So first we will construct the cube. So for that I'm using the true length first. Then in this combination we are observing that the diameter is given as the true radius for the sphere. So this is the basic principle of the isometric projection. Whenever we are drawing the periphery of a sphere or surface of the hemisphere, we are using the true radius. So when that one we are going to use means until we reach the center of the hemisphere or center of the sphere, we are using the isometric scale. We can see here isometric 25 radius, isometric 50 mm height of the cube, isometric 50 mm length of the base edge of the cube here. So while drawing here, in the beginning, I'm going to draw with the true length. So until I reach to this point, the center of this sphere here, and I'm going to use the scale, convert all the dimensions into isometric scale. Then I'm going to use the true radius of the sphere to construct this one. Let's see how I'm going to do this one. So construction line or visible line we are taking here. So start with this point. So in the ribbon bar, this ribbon bar can be utilized to enter the length and angle, respective angles of the isometric box here. So start with this 50 mm length, 30° is the angle. Again 50 mm length, 150° is the angle. Again 50 mm is the length, minus 150° is the angle. Again 50 mm is the length, minus 30° is the angle. The base of the cube is created. So before drawing the vertical edges, you can draw the vertical edges in 90° and 50 height. So instead of that one, the copy of the base I am taking and creating the top surface. For that move option I am going to use here. Select this, copy must be on. Click any corner of the box here. So while lifting here, X movement will not required. So that in the ribbon bar X movement I am making 0. Press enter button. Y 50 mm because height of the cube is also 50. So one copy I am taking. Now connect the visible edges. So this edge also I can draw, but I don't want to keep any hidden elements here. These also I am going to remove. Take the trim option and remove this one. Over the top surface of the cube, the sphere is placed. So first we need to reach the center of the sphere. In order to reach the center of the sphere, top surface of the cube we have to find. For that I'm going to draw the horizontal and vertical lines here. This is the center of the uh, top surface of the cube. From this center to the center of the sphere, I have to move. So here the true length what I used here. This is true length 50 mm. This is true length 50 mm. Okay. Whenever the side length or the in a isometric box having the all edges equal to the 50 mm, then automatically this vertical diagonal what we drawn, this is also become equal to the 50 mm. We can check it also like this. So over this one, the sphere of 50 mm diameter is placed. So from the top center of the cube to the center of the sphere, definitely the half of the diameter of the sphere we need to travel. That is the 25 mm. So for that, what I will do here, for your understanding, I'm use a different line type here. From the center of this one, actually the center comes definitely here because the side length of the cube is 50 mm once again equal to the sphere diameter. So automatically it comes here. So to confirm, let's start the line here because from the top surface of the cube to the center of the sphere, I need to use half diameter, that is half length or half dimension, that is the diameter of the sphere. 50 is there means 25 I need to move in upward direction. So length I will enter 25 here and angle 90°. See, once again here it is coming. That means it shows this corner is going to be the center of the sphere. And if you want, uh, you can show the dimension like this. Okay. So after this here, up to this point, I've used the true length, but with respect to the isometric principle here, we need to use the isometric scale. So until we reach the center of the, in this combination of in these two solids, we need to take care that uh, that radius of the sphere is true radius we are using. So that uh, apart from that, all the dimensions must be in isometric scale. So for that, I reached the center of the sphere. Now I'm going to use the scale option and reducing this one by isometric scale factor, which is 0.815. Here, copy of and place here. So now from this center, a sphere we are drawing, whose radius or diameter is true radius or true diameter, that is 50 So this is how the combination we have to do here. uh, Isometric projection of these two solids. Next step, what I will do, I don't want to keep the hidden elements here. So let's remove this one. Then these dimensions, these are up to the center of the sphere. We converted the length, all the lengths into isoscale, all the scale. So for that, this is what, this is ISO 25. This one I am going to change ISO 25. This is ISO 50. This is also ISO 50. This distance is not required to show here. For the understanding purpose, I shown. What does that means? When a box, equal side box we are constructing in the isometric drawing here, the vertical diagonal what we are creating to in order to find the center. So that vertical diagonal is always equal to the box or edge length here. So in this case, cube means all sides are equal. Because of that reason, this vertical diagonal is also equal. So this can be conveniently used to find the center of this sphere at the corner. So just I'm removing this one. So next, finally, I'm going to 30-degree lines here. The reference line I am going to draw and show the angle. So this is how the isometric projection of the combination of these two solids can be done. If you like this video, do share and like and subscribe to my channel so that I can bring more number of videos to help your learning. Thank you.